So let's do another repair. We have one more Game Gear here that doesn't load a game, so we're going to quickly diagnose this. So let's just jump straight in and make this a nice quick repair video. So we've got here the first one. This is a 2-chip USA version. We're going to start by soldering a ground point on, so we can attach the oscilloscope probe ground lead. We're going to get the clean juice to boot the board. And we're going to get the audio just for a quick test to make sure we're not getting a game. Because if it's already booting, then we know the problem is potentially the customer's game. Get some IPA. Insert into the slot and turn on. Yep, and as thought, we don't have a game boot. We do have red light boot, and we do have a screen. So, knowing that, we can unplug the audio, remove the game, get the oscilloscope, grab it onto the ground probe, and we can start probing these pins. So if we zoom in, bring up the scope, test it's working, yep. Turn on, and let's go to see what we can find. So without any diagram as well, we don't need to know the pins too much. We know there's 5 volt here, some address here, some data here, and we'll get used to the signals by just looking at them. It should be fairly easy to spot a bad signal. Yep, so by default, it's trying to load one of the addresses. So let's just ignore the fact that it's trying to load, because that'll happen when it's bad. You can see that pin doesn't look great. So that's definitely not what we want to see. That's setting above 0 volts, and it's got all kinds of noise and a mixed signal. So that line is suspect. So pin 1, 2, 3, 4, 5, 6 is definitely suspect. Same with 7. So 6 and 7 are a bit suspect. They might be joined together, 6 and 7, which is under the LCD, so we can't really see under there at the minute. The data is possibly normal. That data is also loading, so something's interfering with the data, which you wouldn't expect. And then once we're down to here, yeah, something's putting data on this line, and the only thing that normally does that is the MPU. That's also a damaged trace there going to that pin, so there's quite a few issues here. So other than damaged traces, the main issue I think we're having is if we go to the data pins, these data pins seem to be getting loaded with some data. So for instance there, random data appearing, that is data that shouldn't be appearing, then data changes again as the address is changing. So let's just take a look visually to first see if we can see any kind of shorts that might be causing the issue. So I'm not sure whether that's a short or dirt, but it looks like just normal dirt. That's normal, they're normal. So the data pins from the A6 here seem normal. They don't seem to have a short here. Can't remember whether that's a short there. It was a hairline short. Just turn off and on and make sure that wasn't a problem. That looks like it actually was the problem, or potentially one of the problems, because we saw broken traces as well. Let's go back to the data pins then now. So that's interesting. I should have a look which pin that was, and that was actually just a pin going up. I think those pins just go to the extension port. So let's just take a look at the pins on the 2-chip. Oh no, they're the address lines. So yeah, one of the address lines was shorted together. One of these address lines. So that was causing, strangely, when the address line was shorted, it was causing the data lines to get interference, which is a bit strange. So let's just double check, see if the data interference has gone now. Yeah. That's very interesting. So a short between two address lines was causing something to control the data line. Now, I've never known that. So perhaps when a certain address was signaled, either this chip or the MPU maybe was deciding that at that range of address it's going to interfere with the data line. So that's something to bear in mind as we repair future ones, that actually a shorted address line can cause the data lines to be driven. I'm not sure what's driving it. I'm guessing either MPU. I can't see the RAM. The RAM's just RAM. So when chip select is not enabled, which is pin 6 here, which is high, so it's not enabled, this won't be doing anything. So it could be the MPU or the ASIC. But now that bit is fixed, let's just carry on and probe again. We did see, other than all the data lines being funky and loading data, I did see damaged traces. So ground, ground, ground. We got back to some data, which is all normal. So these are back to address pins. And then if we remember, the pin for if a game is loaded is this one, I think. No, next one coming up. I think it's this one. 5 pins in. Let's just double check that. I'm pretty sure it's the 5 pins in is where the indicator for the data is. 1, 2, 3, 4. Yeah, 5 long pins in is when a game's loaded. So this one's showing there's no game loaded as expected. So that all seems right, but I did see when it was firing that one of these traces near here looked like it was broken. But now we don't have anything controlling the data lines. We'll chuck a game in. And I can't see this loading the game, but let's just chuck the audio back in for 2 seconds in case it does, in case that slight short on the address line was the only issue. Nope, so that's not the only issue. So let's take out the audio and let's probe now with the game loading. So back to the address lines. Now it's not even trying to load. Oh, actually, it might be, but not getting the data, so let's see. So the address pins there, yeah, so it's not getting data. Well, I presume it's not getting data. So there we go. Is that the data line there? No, that's the address line, and then data. It's getting the same data, same data, same data. Now that one is potentially a problem because, yep, that's definitely a problem. So just put a little scrape on there. See if we can see that. Really shouldn't use expensive probe leads to scrape. Let's not set bad examples. Let's use tweezers. So that one is definitely a broken trace. So we'll come back to him in a minute. Just enough to see. And you can see it's a broken trace because as it should look like that, you know, high and low, as we mentioned, the amplitude. This one is clearly trying to do something, but not all the way. It's like half attempted to load. And then you can see if we move the cartridge there. So I'm just wiggling the cartridge. You can see there. So maybe if I hold the cartridge here and just try boot, which maybe you should put some audio in. turn off, hold up, turn on. And that doesn't sound right, so no, it's not just going to be that one, but either way, that's a faulty pin. So let's just carry on. So we have the faulty pin there. Let's check it's still faulty. Yep, it's on and off faulty. It's like, yep, I kind of want to keep it in a faulty position so I know. Wiggle the cartridge a bit. In fact, I'm going to wiggle the cartridge as I'm testing these pins so that I can see if they go from working to failed. I should probably check what this pin is because I'm blindly going at the minute and it might expect it to be data. So, the 5th one's there. Address 10 is fine. Read is fine. And then we have 6 more addresses. See, that one's not good there, so and this is intermittently good or not because this pin goes good or bad depending on when you wiggle the cartridge connector. So that could just be a broken trace. This pin, yeah, so let's just put IPA on that again. And while there's IPA in, which makes the contact a lot more conductive, go onto the faulty pin and turn on. And yeah, you see you get the same issue. So that's probably a broken trace, which you've indicated. That one's okay. That one's okay. That one's also looks like a broken trace. Let's carry on moving down. So now we're 1, 2, 3, 4, 5, 6 off the end, which is 5-volt line, which is right. Yep. M1, which is right. The game load, which seemed to just trigger then. Yep, which is intermittently getting data, so it's partially try and load the game. And then the rest we don't care about, bar, do we have 5 volts, which we do. So we've identified so far 3 faulty pins. And they are this pin, which let's figure out what they are now. So we have D6 is faulty, the data line 6. This faulty pin, which is A8. And then 3 pins later, which is EXM1, which I'm not sure matters too much. I don't really know what that pin does. I've not diagnosed that much to know. So now we know we've got D6, A8, and EXM1 pins faulty on the cartridge. We could go and connect them, but let's first probe over onto the other areas where they should connect. So D6 on the RAM is 4 pins down, so 1, 2, 3, 4. And you can see that pin's fine there. So what that means is the signal from the ASIC, which is sending that, is making its way over to this RAM chip. Yeah, so it's good on this chip here. A8 is pin 4 up from the bottom, and A8's good there, so that's also fine. And EXM1, I don't believe goes anywhere bar straight back to the ASIC. So if we tested the ASIC for both of these pins as well, or for all 3 of these pins, we'd then know the damage is going to the cartridge connector and we can repair that. So A8, if we start with that, it goes no pin, and then it's A0, 1, 2, 3, 4, 5, 6, 7, 8. You can see it's actually not making its way back to the ASIC either. So that means this A8 address is being loaded on the line by the MPU. So the MPU must be setting the address line 8 to the value, and it goes back to the ASIC. So A8 on the MPU is the third pin up here. And you can see that's driving it. So this is the thing currently driving the address and data lines. Address line 8 makes its way over to this chip and is connected. And then on its way over to the cartridge connector, which then is likely to the ASIC, we have a break. So we know we need to repair the A8 trace. That is definitely damaged. The D6 the same. It's fine where it currently is. It's fine on the MPU and the RAM, but it fails here. So let's see if it fails on the ASIC as well. So the ASIC for D6 is this pin here. And all this info is on retro6.wiki. So you can see D6 actually on here is fine. Let's just see if it's still fine on the cartridge connector, because that, I believe, is the intermittent one that's working. Yeah, so that's the one that kind of works and then fails. And we've seen that fail. And it does seem to be based on me bending the board, potentially. Let's make sure we weren't wrong on the one we thought was faulty. See, all these three we mentioned. These three data lines are all actually not quite right. D3, D4, D5. And funnily enough, the one that was faulty doesn't seem bad now. You see the extra pulses. Well, I say it's not normal. Actually, that could be normal because the pulses, if we remove a game, turn off and on. And then put a game in. No, I think that's just when it glitches. I think once the data's merging and glitching, it goes funny. So we're going to leave D6 for now, even though it's suspect, because when you turn it off and on, it's initially fine, and when things get corrupt, it can then mess with the data lines because everything goes out of timing. So I think D6 might be right. A8 might be the only problem, which is this pin here, I believe, which is definitely faulty. The XMP one is definitely faulty, but I'm not sure whether that needs to be connected, so we're going to purposely leave that broken for now and focus on just A8, and that might fix the problem. So if we trace A8, let's just disconnect the power for the minute, disconnect the scope, disconnect the game, and let's just look for a broken trace. So firstly, this is your perfect suspect right here for broken traces. When you see a trace green and it goes to dark green, that's acid corrosion. So if we gently scrape that off, you'll see the resist comes off. So anywhere you see these speckles of dark green, this is a sign of a possibly broken trace. And either way, it's acid damage of the silk screen. So there's always that to be suspect of. But let's not get distracted by lots of potentially looking damaged traces when we've got the oscilloscope and we've seen the damaged trace. So that means the likelihood of these signals aren't important. We do know the signal here is broken. Now it goes from here through two vias underneath this RAM over to the MPU here. Now we've probed the MPU and the RAM and it's fine. But to look at those traces, if I flip the board over, it's one of these two here, I can't remember which. But they look good as well, and we know they're good because we've seen it on the scope. We've seen it go from, I think, originate from here, go through two vias and make it to here. So that trace isn't the bad trace. However, on the way to the cartridge connector, it does go bad. So the next point it leaves, the MPU on the pin 3 underneath the other side of the board. So if we flip it around, here, I believe, I think this is the trace. We can just remove, so we really need to see under here. So let's just remove the LCD. I try and not disturb the LCD where I can help it. but we do need to see under these traces because we know it must break before it gets to this connector, because it literally leaves there and makes its way to that connector, and that connector is no longer getting a signal from the scope, so it must be damage from there. So let's follow it now and let's find our bearings. So the MPU is here on the other side. So right around here, and there we go. So it's this trace, comes along, up, so it's a second trace, along here, all the way across, all the way up. Just put a mark here, so we can point there. I'm just going to power this back up and double check that we have a bad trace there and that we're on the right via. And let's probe on that pin. And yes, you can see there the trace is damaged there. And if we trace it back to where I believe it was this one, so we can gently scrape away a bit of the trace on this, and turn off, turn on, and it's damaged actually already here. So from this via, now that via goes simply straight through from here, and I know this because we have the trace of this board. So let me just turn this off a minute, unplug this. That via goes from there straight underneath here and to the third pin here. So it's got to be damaged. The trace, the via itself must be damaged. So the simple fix for this is I'm just going to run some Kynor wire to the other side of the via to repair the via. Right then. Get some flux on the wire, tin the wire, and then just place the wire in line with the pad you want to solder. And there's the connection. So that's A8. We're going to then just bend this around, and you probably want to use enamel wire more than you want to use Kynor wire for trace repair, but I don't have any on me at the minute, so this will do us for this repair. I'm just going to scrape away, and this is only gently. I'll scrape away a nice long piece of this trace. The V is damaged anyway, so I don't really care about digging into that. Let's just expose all the copper to give us the biggest surface area we can to work with. And there's the trace. Put a little bit of IPA on. Just be careful of the screen when you're putting IPA on, because you don't really want to get IPA on, the screen. So this screen over here, I'm going to keep out the way of the IPA. That cleans that up. Now we need to pre-tin this trace. So we want to lob as much solder on as we can, rub over, and basically the idea is to try and get solder to stick to that trace. So you can rub a little bit, you can clean your iron off, you can go back again, and you can see it's just about starting to tin the trace. There we go. And because we have the via, which is bigger than the trace, wider, it makes it a little bit easier. I'm just going to bend this wire around, cut it roughly to size, expose the end of the wire, more flux, pre-tin the wire, get the tweezers, and you want to try and place the wire touching and let it bridge over, and now gently bend it into position and clean up. If this was enamel wire, this would look a bit neater, but we don't have enamel wire on us, so that's the appearance we get at the minute. Not a messy job, but you know, can be neater if you use thinner wire, enamel coated wire. So that should be good. It's not the worst repair in the world. So that's that trace going over the board to here. Touch on here, and then turn off and on, because I think A8 only loads up at the start. There we go, we now have A8. So let's just presume A8's the only issue, because the other data lines were a bit glitchy, but that could have been because of just probing around and touching other things. It might be the only issue we had was one bad address line, but it does show that one bad address line and one bad short can kind of make the data lines act funny. So it's always best to try and focus on the main problem that you see, the most obvious problem, fix that, and then test again. So with that fixed, I'm going to chuck in Sonic, and we're going to go for a boot again anyway. Let's just plug the audio in, see what we get. And still nothing, so let's probe away. And I can tell by the sound of the audio already it's not going to load, so back on the pins, we have the address line. Oh, actually, tell a lie. Can you hear that? That's Sonic. So it is actually loading. So we have bad audio as well as a loading game. So the game's actually loaded. Let's turn on and off again. Let's prove that then with the test here, where I mentioned about the audio. And you can see there actually, if I probe on here, it's making it work. Now interestingly, I'm basically grounding a pad here. So we have another connection problem somewhere here. So let's just do the obvious in this case for now. Let's just reflow these pins here, because going to ground there seems to fix it. No real reason why. This is just one of those times where there's a problem and touching near the problem seems to solve it. So let's not bother putting too much thought into it. Let's just first reflow these pins. So to reflow them, don't worry about bridging. Just plenty of flux, plenty of solder. Go up, down, and you'll see the solder blob generally follows your iron, and you can drag it down and across. We've gone over the pins we care about, and that's good enough. So let's see if audio is now fixed. Nope, still got bad ground, so I'm just trying to think why. Let me have a look at the pinouts. So we have ground. Technically the pin next to ground is called test, but sound right, which is the pin we're shorting to ground, makes the sound kick in. And it really shouldn't. So let's just open the schematic and see. This sound right to ground, which is basically just pulling one of the channels completely to ground, the sound kicks in. I don't really know why that is, if I'm being honest. So I guess we have to actually analyse this circuit a bit instead of just guessing now. The thing that's thrown me off is accidentally shorting the one of the pins to ground makes the audio work, and that's what's making me confused. I want to kind of know why doing that makes the audio work when it shouldn't. I mean, an obvious thing is to bridge this here, but it makes no sense. So we should follow the schematic instead and actually, fix this the correct way by looking at what's going on. And we've got 5 volts there. So you can see on the scope, that's 5 volts. That should be 2.5. So that means this offset then is losing it. So the problem is the DC bias. I'm guessing when I short to ground, I'm effectively pulling the voltage down. Yep, there you go. So by shorting to ground, I'm taking what should be a 2.5 volt DC bias here, so that the audio can ride on half of the voltage wave. Because it's 5 volts, the signal is already at the max peak of the op amp that's running at 5 volts, so it's basically clipping the audio. So that now explains it. So when I short this, all I'm doing is shorting the 2.5 volt analog DC rail. So now we need to find out why the 2.5 volt rail here is not 2.5 volts. So here's the 2 resistors we're on. I've tested the one side there, it should be 2.5 volts and we're getting 5 volts. That goes into the op amp. The op amp's powered by the 5 volt rail. So because the audio is effectively sitting on the 5 volt rail instead of 2.5, it's too close to the edge. It basically clips off at the 5 volt. So let's have a look at where the 2.5 volts generated. So it's generated here, and it's generated simply through just a voltage divider, so R48 and R49. And those resistors are here. So we've got R48 and R49. And the way it works is we should have 5 volts coming in here. This goes through a resistor divider down to ground here, and this should be 2.5 volts. So my suspicion is 5 volts comes in here, goes through here, and this pad that should be ground has a broken ground. So let's just get the testers into continuity mode, make sure they work, and let's test for ground. And yeah, there's no ground there. So let's just quickly repair that ground with a little wire. And if we just bridge it to the ground of this capacitor here. We should have recovered ground. Now let's plug the gain back in. Plug the audio back in. Plug the power board back in. And I presume now we should have the audio at normal volume, which we do. So let's just turn that down a bit. And importantly, if we test now on the audio pin, you can see we get 2.5 volts. So you can see the offset now is correctly at 2.5 volts, which is why it works. Let's just turn this off, turn it over, and make sure the screen works. Turn the game on. And there you can see we have the game loaded. So there's a little bit of glitch at the start sometimes, which might be that XMP pin. Or I think it's just we've got a bad power connector wire as well, because look at this. So if we hold it in place, it works. But you'll also want to fix this power wire. I'm probably going to make new power wires, to be honest, because there's a lot of these that are faulty, but that's an easy fix. We're not going to bother doing that one on this video. That's literally just a wire. So you can tell it's this, because look at that. But if you get the wire in the right place, console will boot and everything's working. So that's another one repaired. That was quite interesting because we learned a few things. I personally learned that when the address line is bad, so in this case address 8, I believe the pin was, the data lines were being driven with some kind of strange data. So my thought is, I think the ASIC does drive the data lines, and it's listening out for a certain address of when to control the data, because clearly the MPU is the thing driving the data line, because when it was broken, the address and data lines were coming from here and making their way to the cartridge in the ASIC. So this MPU is the thing that is actually reading the game in and talking to the cartridge in the MPU and the ASIC. So I reckon when the ASIC receives a certain address, it decides to control the data lines, irrelevant of the cartridge. So it's not really aware of the cartridge, I don't think. So that's something to be aware of. Fix the address lines first because they can affect the data lines. So that was worth noting. And then this has obviously got a bad power cord. And also we had a missing ground, which was an easy fix for the audio. And you get to see the reason for the 2.5 volt offset on audio, because without that, the audio clips at the high end. So hopefully that was useful. If you're enjoying these and you want any kind of consoles repaired, any retro consoles, modern consoles, feel free to just send them to me. I repair all of them free of charge if you send them in, and I'll do a YouTube video on them. You do just have to bear in mind there's a backlog of consoles I work through casually, so don't expect your console back in any specific time. But if you want to see me repair anything, just ship it to me with a note of the issues and I'll happily repair them. I'll catch you guys in the next one.